Hello and welcome to the appliedR channel. In this video I'm going to be talking about dealing with missing values in R. Now I'm an economist by background and I deal with data all the time and I find these functions very useful. There are 4 sections to this video. In the first part I'll talk about identifying where the missing values are. The second part is on extracting missing values. The third part is on replacing the missing values, and the fourth part is on using the dplyr package in dealing with missing values. Firstly, let's just have a look at our data frame. I've named our data frame table 1, so if we just have a look at that, we can see that there are 4 columns, 5 rows, and I've put 3 NAs in there. Now typically your data is probably going to be much larger than this, so you won't be able to just eyeball the data to figure out where these missing values are. So the first thing you might want to do is find out whether there are any missing values. So the function to use for that is anyNA followed by your data frame within the brackets. So if I just run that, we get this true statement in our console here on the bottom left, which indicates that we do have missing values. And missing values, I should say, are noted as NAs in R. So you might want to know how many NAs there are, and you can use the sum function for that. Within the sum function, you use the is.na function and your data frame. So let's just have a look at this is.na function and what it's doing to our data frame. So you can see in our console, we get these false and true statements for our data frame. The true statements are where the NAs are, and everything else we get false. Now in the background, it's important to know that we actually have zeros and ones. So ones for where the true statements are and zeros for the false statements, and I can show you that by multiplying that table by 1. So if I just run that section there, now that table is multiplied by 1, and you can see where the true statements are, we get the ones. So if we then run that whole line, it's just going to sum up that table and give us 3 in our console. So we have 3 NAs. Another way of doing that is using the table function, and within that we use the is.na function followed by our data frame. So let me just run that and I'll talk you through what's going on. So we now get the number of false and true statements in our data frame. So you can see that we have 3 true statements. That means we have 3 NAs. And if you want to know what the percentage of NAs in our data frame is, we can use the table function similar to what I used above. So this is exactly the same as above, and all I'm doing is dividing that by the number of observations in our whole data frame. So essentially multiplying it by the number of rows with the number of columns here. So if I run that whole line, we get 15% for true. So 15% of the data are missing values. Now to find out which rows have NAs, you can use the which function, and then within the round brackets, I've put the exclamation mark, which stands for not. So it's an operator and it stands for not. And the complete.cases function followed by the data frame. So let's just have a look at this complete.cases function. So that's essentially going through row by row our data frame and telling us whether we have a complete cases for each row. And complete cases means no missing values, so we have complete data. So we can see that the first 2 rows are true statements, so we don't have any missing values, but row 3 and row 5 are false statements, meaning we have missing values there. So by putting this exclamation mark, we're saying we're not interested in complete cases, so give us the opposite of that. Give us the row numbers where we have the missing values. That's what this which function is doing. So if I run that and we look at in our console, we get 3 and 5, and we look in our data frame, we can see that rows 3 and row 5 have NA. Okay, you might be interested in a particular column, so in this example, which rows in column 2 have NAs. Again, we use the which function. Within that, we use the is.na function, and then you put the column that you're interested in. To do that, you write your data frame, the $sign, which indicates you're going to choose a column. So we choose column 2, and if I run that whole line of code, we get 3. So column 2, row 3 has an NA, and we look at our table, row 3 in column 2 has an NA. Now, how many NAs are there in each column? Well, we can use the col_sums function followed by the is.na table and your data frame. So if I just run this part just to remind ourselves what that is doing. So the is.na function is just going to give us the true or false statements for our whole data frame, and when we use that with the col_sums function, what we're doing is just summing up all of the columns. So let's just run that. You can see that columns 1 and 4 sum up to 0 because we just have a bunch of false statements in there. Remember, false statements equate to 0. Column 2 sums up to 1, and column 3 sums up to 2 because we have 1 and 2 true statements respectively in those columns, and the true statements, as we discussed earlier, equate to 1s. Now, to find out how many NAs in a particular column, we can just use the sum function followed by the is.na function, and we put our data frame and the column that we're interested in. So if I just run that, so for column 3 we have 2 NAs. Remember, if you look at column 3 here, we have 2 NAs in there. Now, to find out the percentage of NAs in, say, column 3, similar to above, we use the sum function followed by is.na function and the column we're interested in, and then we divide that by the number of rows in table 1. So if I just run that, we can see in our console here, column 3 has 40% NAs. Now let's move on to the next part of the video, which is on extracting rows or columns. Now, one of the first things you might want to do is just omit all of the NAs, and the function to use is na.omit followed by your data frame within round brackets. So if I just run that, so now it's omitted rows 3 and 5 which had NA. So if we have a look at our table, rows 3 and 5 have NAs, and those have been omitted. And what you can do is you can just assign. So this is the assign key, which is less than and minus sign. You can assign that to a new data frame here. Here I'm calling it new table. So if I run that whole line, and if we look at our global environment here on the top right, I've created this new data frame called new table. If I click on that, so it's a new data frame with the missing values omitted. What about if you want to extract rows that have NAs? Well, we can write our data frame and then open up square brackets, and then we can write our condition. So our condition is not complete.cases and our data frame. So we're looking at so we want the opposite of complete cases, i.e. the rows that have NAs. And then if you can see right at the end, we have a comma as well. So when you're opening up square brackets with your data frame, if you put a comma, that indicates, that highlights whether you're going to be sort of interested in the rows or columns. So when you put your condition on the left side of the comma, that means you're interested in rows. If you were to put your condition on the right side, and that means you're interested in columns. So let's just run that whole line of code. And as you can see, rows 3 and 5 have NAs, so we get given those rows. And if you want to extract rows in the whole table that don't have NAs in just column 2, so So essentially you're omitting the NAs from column 2 and you're ignoring any other NAs in any other column. Okay, so we write our data frame, you open up square brackets again, and on the left side of the comma we write our condition. So our condition is not is.na, and our column, the column that we're interested in. So our data frame, the $, and then the column. So I'll just run that. And there you go. So you can see that the NA that was in column 2, so if I just bring up our table 1 again, so we had an NA in column 2 here that has now been omitted. That whole row has been omitted, and any other NAs in any other column have been ignored. This is particularly useful if, for example, for your modeling, column 2 is important and you want to get rid of all the missing values, but you're not too bothered about any other columns because they're not as important for your modeling. Now, what about extracting columns that don't have any NAs? Well, we write our data frame, you open up square brackets, and this time on the right side of the comma we write our condition, because remember we're interested in the columns, and our condition is colsums function, and within that we put the is.na function and our table. So let's just break this down into bite-sized chunks. So let's have a look at what this is.na function is doing to our data frame. If I run that, so we get the true and false statements for our data frame, and then if we sum up all of the columns, we're interested in the values that equate to 0. So when you're writing a condition with the equal sign, you must use two equal signs together. So this should give us the columns that don't have any missing values because they equate to zeros. So that should give us column 4 and column 1. So let's just run that line of code, and as you can see in our console on the left, bottom left. Now if we want to extract columns that have fewer than 40% NAs, we write our data frame, we open up square brackets, and on the right side of the comma we write our condition. Our condition in this case is the colsums function followed by the is.na function, and then now we're saying give us the result that is less than this part of the equation, which is essentially the number of rows times 40%. So if I just kind of run that, remember in our data frame, which is table 1, we have 5 rows. So 5 times 0.4, 40% of 5 is 2. So what that's going to give us is the columns. So if I just run this part of the code here, that's just going to give us the columns that have fewer than 2. So if I run this line of code, we can see that it's omitted column 3 here. That's because column 3 had 2 NAs, and we're interested in the column that has fewer than 2 NAs, because 2 NAs, remember, is 40%. We can check the percentage of NAs in each column as well. So we use the colsums function, followed by the is.na function and our data frame, and if we divide that by the number of rows in our data frame, you can see that column 3 has 40% NA. Now we move on to the third part of the video, which is on replacing our NAs, and in this first example we're going to be replacing the NAs with zeros. So we can use the replace function. The first argument of that is going to be your data frame, and the second argument, which is labeled as this list argument, is going to be our condition. So this is our condition argument. Third argument is the value we want to replace the NAs with. So if I just run this part of the code, as you can see that the NAs have been replaced by 0. So if we look at our table 1, we had NAs in column 2 and column 3. Those have been replaced by zeros. Here you can see that in our console at the bottom left. Okay, and then you can assign that to a new data frame. That's what I'm doing here. I'm assigning it, I'm calling the new data frame replace NA table. So if I run that whole line of code and we look in our global environment here, the new data frame replace NA table is here, and if I click on that, there you go, you can see the new data frame with the zeros being replaced here for where the NAs were. So the NAs have been replaced by the zeros. You can do that directly into your table, so this is a shorter way of doing it, but this is going to override your table. So you write your data frame, you open up the square brackets, and within the square brackets you put your condition. So let's just remind ourselves what this condition is, the is.na function. So this is going to give us the true and false statements for all of the data in our table. So wherever there is a true statement, it's going to replace that with a 0. So if I just run that now, and then we look at our table, table 1. So table 1 has now been overridden with the new conditions. So all of the NAs have now been replaced with zeros. So the main difference between the replace function method and using your data frame directly is that the data frame here is going to override the data frame method here is going to override your original data frame, whereas with the replace function you can create a new data frame. So I'm just going to bring back the original data frame. So if we look at our table 1 now, the original data frame is back with the NAs in columns 2 and 3. Now you might want to replace NAs in a particular column. In this example, column 3 with zeros. Similar to above, you use the replace function. You can then choose the column you're interested in, so that's your data frame, the $, and then the column, and then our condition is the second argument, and the third argument is the values we want to replace the NAs with. And then so if I just run that, you can see that the NAs in row 3 and row 5 have been replaced. So you can actually kind of replace this, you can actually override and replace the column 3 in your original data frame. So that's what I'm doing here. So I'm just saying, just go to the data frame and column 3 and just put the results from this in there. So if I just run that whole thing, and then if we go to our table 1 here, you can see that column 3, the NAs have been replaced. The NA in column 2 still remains there because we haven't done anything to that. Okay, so you can do that directly through the second method as well. So if I just bring back the original data frame here in our table 1, you can see the original data frame with the NAs are back. So you can, so the second method is the data frame method. So you put your data frame, $, and the column, and you open up these square brackets, and you write your condition. It's the same condition as we used above. Within the so you write that condition within the square brackets, and then you assign the value that you want for wherever that condition holds. So if I run that and we look at our table 1, and you can see that the NAs in column 3 have been replaced by zeros. So I'm just going to bring back my original data frame. So if you have a look, the original data frame is back. Okay. Now, moving on from NAs, you might want to replace particular values. In our example, we're going to replace the value 13 in our data frame with the value 0. So we can use replace, and the first argument, which is a data frame, our condition here is our data frame, and then the less than sign and 13, and the values we want to replace for wherever that condition holds. So let's just have a look at this condition first. I'm just going to run that. So that's going to give us the true and false statements for the whole table, and wherever that condition holds, you're going to have a true statement here. And essentially what you're doing is you're saying, right, replace all of those true statements with the value 0. So if I run that, there you go. So wherever there were true statements, they've been replaced by zeros there. So another way of doing that, the second method, is directly through the data frame. So you write your data frame, you open up square brackets, and then you write your condition inside the square brackets, and then you assign the value that you want to replace all of the true statements with. So if I just run that, and if we look at our table 1, you can see from our table 1 that anything less than 13 has been replaced by 0. The NAs have been left as they are. Okay, so I'm just going to bring back our original data frame again. So if we look at our table 1, the original data frame is back. Now you might want to replace values that are below 3 in, say, column 1 with 0. So here we're just interested in a particular column. Again, you can use the replace function. The first argument is going to be the column you're interested in, and then your condition, and then the values you want to replace where that condition holds. So if I just kind of run that, you can see that in column 1, any value that is less than 3 has been replaced by 0. So rows 1 and 2 were less than 0. So if we look at our table, see column 1, rows 1 and 2, they're less than 3, so they've been replaced by zeros. Okay. The second method again is using the data frame. So you write your data frame, the $, and the column you're interested in, and open up the square brackets, and within the square brackets you write your condition, and then you assign the values for wherever that condition holds. So if I just run that, and we look at our table 1, you can see that column 1, first 2 rows have been replaced with zeros. Okay. Right, I'm just going to bring back the original data frame. Let's have a look. There we go, we have the original data frame back. Now, the last part of the video is on using dplyr to deal with missing values. I'm going to assume that you already have dplyr installed. To upload it, I use the library function and dplyr. So if I just run that, that's now uploaded. I can now use the dplyr commands. The first thing I'm going to show you is how to extract rows that don't have any missing values. So we're going to omit the missing values. So we say, right, go to our table 1, which is our data frame, and then we have this pipe operator, which is percentage greater than percentage, and you interpret that as and then. So we're saying go to table 1 and then filter by complete cases, and in brackets you put a dot. The dot stands for all of the columns. Okay, so we're interested in all of the columns, and we're interested in the complete cases. So the rows that do not have any NAs, that's what we're interested in. So if I run that, and there we go. So any row that has an NA has been omitted, and we can see from our table 1, so if we look at our table 1, so row 3 had an NA and row 5 had an NA, they've been omitted. Now if you want to extract rows that don't have NAs in, say, in a particular column, so column 2 in this example, so we're only interested in column 2, so we say, right, go to our data frame, which is table 1, and then filter by not is.na in column 2. Okay, so we're not interested in the NAs in column 2, right? So give us all of the values that do not have NAs based on column 2. So if I just run that, there you go. So column 2, the NA, if we look at our data, so table 1, so column 2 had an NA in row 3 that's now been omitted, but that whole row has been omitted for the whole table. Okay, so there is another NA in column 3, row 5, but that's been ignored because our condition was to just focus on column 2. And this is because, you know, column 2 might be important for your modeling. You want to make sure that you don't have any missing values from column 2, for example. Okay, that's the end of the video. Thank you very much for watching, and please feel free to leave comments.